Презентацию запустите.
Good afternoon, distinguished colleagues. We start our section. Our section is entitled Digital Transformation of Russian Enterprises Based on Intellectual Technologies. Unfortunately, Mr. Lugachev was not able to attend. That means that I'm going to be the moderator, Yuri Tilnov. And first of all, I would like to say a few words. It will be an introduction concerning some topics which will be covered during our section, why they are relevant. And I think that I will start immediately with a very brief presentation, and later on my colleagues will elaborate on the issue on the usage of digital technologies and intellectual technologies in our economy. Okay, digital transformation. Digital transformation for production enterprises. It's a sign of our time. It is included into the strategies of many ministries throughout different companies in Russia. We see one more speaker is coming, and it is the top priority area for the development of our economy. Why? Because digital transformation triggers the deep-root changes of all business models of the enterprise work and operation. But those changes should be not for the sake of the changes themselves, but to improve the efficiency, the competence of the enterprise. And you can see that all the countries are currently in the process of digital transformation, and Russia is not excluded from that trend. We also have some achievements in that part. And I would like to mention that, yes, of course, the digital transformation is based on the end-to-end digital technologies. And I'm sure that you are very well aware what I mean by that. That is the Internet of Things, artificial intelligence, that's the processing of big data, new industrial technologies, and many other digital technologies. And all those types of technologies are actually currently used by the digital platforms. And now intellectual technologies are currently put in avant-garde as the task of the intellectual technologies is to automate the decision-making process, and probably that is the key task and the key component of the management system. We need to ensure that the decisions are taken promptly and efficiently. In any way, those issues will be brought up during today's section, and I would also like to give the idea of the key aspects of implementation of the key technologies. But the most important thing is to make sure that those technologies are implemented in the comprehensive business and industrial processes, to make sure that this is not some local automation, for example, introduction of automated production lines. it's not a big deal. It's not something really new. We used to have a lot of automation in some senses, for example, with the processing of technological information, when the data was transferred to the automated systems for management. But all in all, we should consider the new aspects, and indeed, some aspects are totally new. Could you switch to the next slide, please? Oh, it worked. Here we are. So let's consider such key areas and aspects of implementation of digital technologies. Let's see which areas are using that technologies. Functional areas, first of all, and let's consider the role of the intellectual technologies within that. First of all, that is the intellectual management of the life cycle of production and production of goods and services. When we speak about life cycle management, we can also say that this is also the end-to-end process with all the stages, starting from the project design, then production, making sure that the relationship between all the parties and counterparties are established. In other way, it's a pretty comprehensive and complex work, and you need to automate the whole chain. To do that, we need to use a single information environment. When you create the corresponding digital storages and directories, then they are transformed into many digital twins when each asset, fixed asset, production asset, is having its digital twin, and that digital twin accumulates all the data, all the digital flows, and on the other hand, it processes the flows, and it also ensures that the physical objects are impacted correspondingly. In that case, we will have the digital twin system, which is united into such a concept as digital threads, and that concept follows the whole chain at all the stages of the life cycle. That means that the key problem is to arrange such data flows to implement the multi-agent systems if we speak about AR. That means that the management becomes more complex and more complicated. So we may mention a few stages, and the first stage, which is very important, that is development of the product design. And that design unites the multifunctional teams. Those multifunctional teams may include the teams of different enterprises. You need to make sure that the work of IT specialists is synchronized. You have to introduce the models for the management of such resources and to ensure their interaction. In this case, the AI is used very well. Then if we continue following the life cycle, then of course we will see the stage for technological preparation of the production, and then the production itself. When we arrange digital factories, conveyors, what is already implemented in the workshop management system or plant management system. The calendar plans are being created in such systems. But when we improve such process, we need to take into account that each asset in such a chain is a separate object within a system. We understand that the arrangement of such a process is pretty complex. We need to use dynamic intellectual systems which respond to a particular event in an online mode, in real time. And in this case, dynamic intellectual systems are being used. When we continue speaking about the supply chain and about the intellectual management of those chain, it's again the chain within the life cycle of the product. And in this case, we speak about supply chain management, and this is something external. So first of all, you start with the internal process, then the external process. You use flexible systems which are using ecosystems around the enterprise. Then you also create the network of enterprises. That means that the enterprise itself has to act as a dynamic actor. Sometimes such enterprise may be even created specifically for a project. And it's very important to bear in mind that it should be dynamic. One more area, that is the intellectual management of assets, such assets as equipment, production lines, analysis of their performance. What's new there? Economics transfers and shifts from production to service. That means you do not just sell your equipment, but you lease it out. And then you trace that equipment using the IoT. You can monitor the state of the equipment. You can take the decision about the maintenance, the repair, the replacement of such equipment. And that information is transferred directly to the supplier, to the vendor. And that is an innovation which is supported by technologies. And those are the end-to-end technologies. And I speak about the dynamic intellectual systems as well. That was the brief introduction, a brief review. So what we are going to discuss during our section in more details. In our section, we have three big problems to be discussed. First of all, that is the issue related to the enabling of trust to intellectual systems, because the intellectual systems which I already mentioned, where everything is automated, it is difficult to understand what are the errors, what you should do with the error if it occurs, how to increase the credibility of such system. And I also spoke about the big data processing. For example, when the production process generates really huge amount of data, and actually each piece of equipment creates a lot of data. That means that you need to identify some trends, and for this purpose we use some new for production methods of machine learning, neural networks. In general, such methods are not transparent. It's actually a black box. That's why we need to have an explanation how such machine learning algorithms work, how that neural networks work, and Boris Kobrynsky is going to speak up about that topic. And also, we need to test that systems to the necessary extent. We need to make sure that the information system is of high quality and it is reliable. And then we will have another speaker, Boris Pozin, who will speak about that topic. I will provide all the details about the speakers when I give the floor to them. Then also the problem of interaction between the economic subjects. We need to remember that we still have a human factor. Human beings interact not only with each other, but also with all different information systems. And we may encounter the problem of trust. And Dmitry Kozhevnikov will speak about this. What else? It's again about dynamics, about dynamic intellectual systems. Dynamics is very important part. We need to manage time. It is a difficult intellectual task, but on the other hand, it is also applied to economics. On the one hand, it should be dynamic, but on the other hand, you need to ensure business continuity and production continuity. And that economic component will be reflected in the speech of Kirill Skripkin. Then we are also going to speak about different aspects, for example, network schedules and chats. It will be covered by Evgeny Zinder. He is in St. Petersburg. We have the video recording of his speech. And finally, we will speak about the building of efficient digital platforms which would unite all the mentioned digital technologies. That will be covered by Marina Anshina and Yuri Lyamin. I believe this will be a very interesting problem. That's why I suggest you not to ask anything right now, but I would prefer to give the floor to the first speaker, and at the end, if we still have some time, we will have a Q&A section. Thank you.
The floor goes to the chair of the Scientific Council of the Russian Association of Artificial Intelligence, Doctor of Medicine, Professor Boris Kobrynsky. And he is a professor in a number of reputable universities in Moscow State University, Medical University. Please have the floor, Boris. Thank you. Distinguished colleagues, Yuri, will you give me a pointer? Yes. The problem of trust to the AI systems. It is increasing day to day, and AI has been in place, at least the definition, has been in place since 1956, once it was adopted by John McCarthy. And the first systems emerged in the beginning of the 70s, by the mid-70s of last century. and they were like the expert systems. And nowadays we face a variety of methods and technologies. This is not the same for artificial intelligence, like machine learning technology, deep neural networks. These are technologies, but unfortunately, they are some unexplainable black boxes for us. And how to treat the interpretation and what can we consider as a transparency and a user in the end of the day. It does not care which method or technology is being used while the system was built. And the result, this is what it matters. And whether it's a astronaut, a pilot, a doctor, a physician, or a person engaged in manufacturing, and shall a human agree, if this is a human-machine system, shall a human agree with the machine or disagree with the machine approach? There are two ways to agree or disagree with the machine. Imagine he agrees and a disaster happened, like an industrial accident happened or violation of the process happened. Who is responsible? Is it the system? No, human. And legally, humans shall bear responsibility another way. A human being made his or her own decision, but it was wrong. And he said, why you failed to use the modern system? And these systems can surpass humans. This is also wrong, to surpass humans. It's not possible for these systems. They can surpass a level of special people in specific situations, but not overall the human level. They will propose something instead of EMC to the power of 2. They will never propose something brand new, but they can assist. And that's why the problem of trust is so versatile. And today, the definition of where human is located, where human is placed. And on this slide, we show what our colleagues from abroad proposed. Human in a contour and over the contour, beyond the contour. And if the system can act in line with its own recommendations, but under consent of human, this is a human-machine intellectual system. So a human is interacting with this system. It is in the control, and the final decision is associated with his actions. If this is above, if human is above, then the system can act in line with its own recommendations, but human can have a veto right. This is a high level where something is watching the system and put a veto. And the human in the outline, in the loop, above the contour, this circle. So the system can act independently without human interaction. And we were talking about dynamic systems that operate without intervention from humans. Going back to the veto right, sometimes spaceship that comes to the station fail to dock in automated mode and they switch to the manual. It means that automated system and one way or another humans will see what is happening, and if they realize that either station or ship will be damaged, the humans, they place a veto and they take it over. And to all these 3 points, we need to have a different level of trust. And without intervention of humans, these are robots. We have so many robots. Manipulators can be called robots, intellectual manipulators, but we also have manipulators, robots, they act on their own. This is outside the contour, outside the circle, outside the loop. And And we have a value-oriented engineering definition. It's like a concept. What is it? We fail to consider it. And this is a rather new concept in AI. And AI has been in place for 70 years already, 65 years. And this is a earlier anticipation of potential risks. This is something that a developer needs to be mindful in advance. What are the risks? At what steps? Design, development of a software. This is before the rollout, the implementation. It needs to be specified, and then trust goes up to the system because the user sees and knows what are the risks were considered and at which steps and what was failed to be considered. And in these cases, we need to consider the sources of knowledge. On the one hand, knowledge and data, developer need to consider it, and we will talk more about data, and to consider non-standard situations, contingency situations. And today we have a lot of contingencies around us. Just a simple example for you. Everybody knows what COVID means, and this is a viral infection, and we have so many variants. They are not standard. We had a standard virus, typical virus, but now they are untypical, non-typical variants. And this is something, once we take a look at something, we might have different variants. And these borderline elements of the aggregate of data, as academician Larichev called them, these borderline rather rare elements, they also need to be considered. Because the standard situation, we know what to do, but in non-standard situation and contingency situation, we might face a problem. And today's problem relates to machine learning and big data. We're permanently talking big data. It's a buzzword, and machine learning is a buzzword. It enables us to find new knowledge, to extract new information. In some of the cases, yes. But unfortunately, we need to consider that these data sets, enormously big data sets. Speaking about big data, initially we talked about hundreds of thousands of observations, thousands, and then hundreds of thousands during one large-scale conference. There was a question asked to one of to Vladimir Gorodetsky. He is a renowned specialist in our area. And he was asked, we are trying to work with the small data, and we fail. And he repeatedly said, you cannot do it. And they said, no, we don't have other data. That's why we have to use small data. But there are restrictions, limitations. You might want to use small data, but you need to have other approach. And now the new approach is emerging, but big data, this is something that we have to deal with. They need to be verified and of high quality. Verified, what it means? It means it's clear for you, high quality over a fixed period of time. Over a fixed period of time, the business processes are changing sometimes, and if the business processes are modified, we cannot merge data from the previous business process and mix it with today's business process and say we have big data. We cannot do it. The unchangeability of the data itself, the business processes are fixed. For example, equipment is replaced with the different capacity. We have something new in the picture. But the previous data were of the worst quality, and we cannot merge this data. And so unchangeability of the regulations, if regulatory framework is changed, we also need to consider it. And unchangeability of all the processes, the hardware, everything, unfortunately, is not considered always. And then the question of trust comes into picture. Shall we have trust to this data or not? And point two, quite often we hear that data is published and 90+%, sometimes 98% of results are brilliant. But once you take a deeper look into these publications, it turns that during the system testing, the authors, with their own hands, maybe in the extended sampling, the same place, they got the top-level results. Wonderful. But verification, validation is there. Yes, they validated on the same material. But if we move to another place, where the same task has been tackled, but there are differences there, and try to look whether it works there or not. Maybe it will be 78 instead of 98. The result is slightly different. This is all about trust to the data. If we fail to do so, we cannot trust our systems. And people, humans, they don't want to trust them. There are people who are so easy to trust. Some people will have blind trust, and they say math is a great science. So it means everything is correct in math. And there are people of extremes. They never believe something, but 80% are in the middle. 80%. This is our focus group. But the man who got a certain system and is ready to use it, he needs to be aware and that why the decision to be made for granted. And if someone tells him, press this button, it will be all right. And this man is not sure whether he has to do so or not. You need to be explained. Always explanation needs to be there. The first systems in the world, like US system of 1976, 77, had explanations. Then we switched to machine learning, to deep neural networks, to the black box systems. So we got the problem. And now we need explanations. Of course, we need explanations, but we had explanations back then. And now what do we need to do? The interpretation of the interpretation of the balances that were used in the systems enable to fine-tune, to debug the system and get fine results. But for a user, maybe a user does not care, or maybe it does not give anything in terms of better understanding. So this transparency, certain transparency, and based in interpretation, we need an interpretation. So this is not an explanation. Explanation is how and why. How and why. How the system made this decision and why. And what chain of, what sequence of steps brought us to this decision, sequence of parameters enabled to express these hypotheses. And it's not enough. We need to understand to whom we're talking about. What is the user level we're dealing with? Users of different levels. The executors of the lower level, higher level manager, in case of decision making, in a certain area where there are several people are involved. And each one of these people, in line with this person's level and the framework, need to receive understandable explanations, especially for the critical applications. Critical applications exist in a number of manufacturing sites in avionics, in defense industry, in medicine, in aircraft making. Yes, please finish. Yuri, you said that we have extra time, but probably that's why I just overusing, abusing my time. Sorry. And we have a life cycle concept for any product, for any software, and I have a question. This product, shall we extend the life? Shall we extend the life? Do we make modifications? Then we change the version. We make serious changes and expertise of the life cycle. So to have trust to the new system, it needs to be different. In one case, we need to have a correction of a small scale, in another case of a greater scale. So this is still uncharted waters, both for Russia and abroad. But this is very urgent. This is necessary. And we cannot proceed without it. So thank you for your attention. I'm done. Maybe we can entertain one or couple of questions. We don't have time for more questions. Okay. Yes, this is a long-standing question. I already made a presentation on this subject. Maybe I'm wrong. Maybe. Now, fintech is increasingly dealing with loans and deposits. So fintech takes money and places it on a deposit, and fintech provides loans. It can be called differently, but loans are being provided. Even maybe it's P2P, it doesn't matter. And fintech emerged after the crisis of 2008 and 2009. And consequently, whatever training and real data sets you just described to us, they are related to the period of economic uprise. And can it be done that we can extract something useful for the downturn period? And maybe the data sets that we used for machine learning will not work during the crisis period. Do you see the question? It's a rather interesting and challenging question. In fact, the problem on what can be used or what portion of data can be used, it needs to be decided by the subject matter experts. It's very specialized. The subject matter, this is a business or economics or finance and a narrow area. This is what your question is related to. So this deposits and loans, like specialized, especially skilled experts should say, most likely something can be used from the old data sets, but they need to set the borders or say this is not applicable. That's why selection at the level of knowledge, expertise, and data. Data is something that can or cannot be used. This is the only answer I can give. Maybe a hybrid system, hybrid systems can be used. Like the first level expert system determines whether it's feasible, not feasible to apply, and then, Yuri, you are right, because I started. One of the possible approaches that we are working on how to switch from the black box to an explanation. We need to merge the expert systems with the systems based on machine learning and deep neural networks. These are the so-called hybrid systems. I propose a number of such solutions, and we are trying to implement them one way or another, at least to start implementing. So far, we don't have such systems in place. To be honest, I'm really curious on machine learning tasks. And one question, maybe it's already answered. I just ignorant of it. So we've got new entity, big data, and it is determined by the top level. You gave this definition. We have like the essence, the core, but also the quantity of data sets. Are there any works, publications? What the data set size should be to make it feasible, to make it operable from the math perspective? What is the feasible data set size? No real papers that can be trustworthy. I don't know of where the accuracy is proved. Most likely, we have the level of considerations, and at the lower level, we have some approaches to work with the small data, but we have a certain error margin there. And I work with the banks, and the banks, they anticipate, they predict strategies for the bank towards the customer. And the banks can offend the customers unintentionally, for example. So I think this is a serious question, but unfortunately, so far we don't have a clear system to deal with it.
I would like to give the floor to our next speaker, to Boris Pozin. He is the technical director and professor of the High School of Economics, doctor of engineering, and he is also the representative of ES Leasing. And he's going to speak about the creation of the responsible automated systems. First of all, I would like to start my speech and aim my speech at those who see their future as the developers of complicated program complexes. And we need to understand, first of all, what could be automated. And then we need to digitalize that area and then transfer those data using algorithms to some recommendations how we can use it in a particular economics area, for example, agriculture or production. Those who are interested in that area, could you share your opinion about the number of programs which are developed for training in our country, our own developments, domestic ones? It's in between 10 and 20. And what is about the remaining percentage? You cannot make a miracle. For example, we have the budgeting system working, and you need to know from where you can take all the other data. We are not having 20 or 30 million of programmers in our country. It's around 2, maybe 3 million of programmers. And I would like to say that the turning point in that era happened around 10 or maybe 5 years ago, and that was due to the effort of Professor Ivannikov, that is the team who worked on with the open source solutions. When we started to work with the Open Code Society, we found out that we have a lot of prototype solutions, and some of them work as the industrial devices, and we started to include the open source solutions into our training complexes. And as of today, we have the following number of such solutions from 78 to 80% of code. Do you think it's a lot? I think we need to consider different factors about sufficiency and the functionality of the open code. Let's assume that everything is fine with those parameters. But recently, people are reviewing their position concerning being friendly to competitors. On the one hand, open code is being created by the non-commercial organizations or by some individuals. But in this case, there is a question. Could it happen that there could be some malware? Please raise your hands, those who can do anything with Python. I don't see a lot of people. And what about Java? Okay, and what about C or C++? Work or learn it? Well, I see that we have some people, not a very great amount of such people in our audience. Okay, colleagues, the compilators which you use in your work, they are not pure. They are not clean of potential vulnerabilities. Sometimes that was not intentional, but sometimes it was. That's why we have the necessity to develop the technologies to decrease the cybersecurity risks when we create the up-to-date automated systems here in Russia. Today we have a free association which unites more than 500 specialists who work with that problem at the enterprises at production on a daily basis. They are searching for vulnerabilities on the one side and for the unmet needs on the other side. Those are like Kaspersky Laboratory. Just name any of the top 20 software companies in Russia. This is the new role of the open source solutions in the software. And that new role triggered the necessity to change the life cycle of the software. And probably we should use some artificial intelligence, or maybe not use artificial intelligence, or maybe not use those options at all. And once again, the biggest issue is to make sure that such open source codes do not have any intended or unintended vulnerabilities or malware. And when we speak about the systems and technologies which should support the open source solutions, we need to consider the import substituting products. We need to create a whole range of such products, and probably we should also use the ready-to-use solutions. But in this case, if we use that ready-to-use solutions, then we are at risk that some vulnerabilities will be also introduced into the code created by a developer. That's why we need to consider the possibility to create the responsible systems. It is not what is mandatory, but we need to ensure that the risks for the, for example, defense industry is mitigated. And we need to make sure that we take it into consideration. What are the trends in the area? First of all, we need to understand what we should search for in the code. What do we mean by vulnerabilities? Who should search for them? What are the criteria to understand if there are some vulnerability or not? And we have the standards, state standards in that area that was provided for in 2016. We have the method which explain what the vulnerability is and how to search for vulnerabilities. And although the organizations participate in the work of the community, they are certified. And in this case, we need a lot of resources and skills, the necessity to be aware about all the necessary requirements and principles. And one of the AI centers, that is the center headed by academic Aratisyan, and he is the person who dedicated himself to the solution of that topics. Samsung is currently using the solution to check their own developments. If, for example, you have a smartphone or some other innovative devices of Samsung or Huawei companies, then they were also already verified. I am going to be brief. I have one more slide left. I want to explain which documents should be used to that area, in that area. Just give me a minute, I'm trying to find the necessary slide. Here is the toolkit, which is currently used. There is a security group. So those products are available at the moment. They are publicly available, and there are also licensed products for those who use them professionally. And currently we are preparing the program to enhance the training in this area. Thank you very much for such an interesting presentation. And the next speaker will be Dmitry Kozhevnikov. He's the chairman of the Council of the National Association of Enterprise Architects, Russian Technology University Miria, and he's going to speak about the economic transaction and trust in the era of digital economy. Dear colleagues, this is the topic I first touched in 2017, and I was hardly criticized by my colleagues. Now I received some practical on-hand results, and I would like to show you. Okay, I'm sorry for the quality of the picture. First of all, we speak about the economic transaction as about the process of interaction between two parties which make a decision on conclusion of a deal. But as we understand, two parties will turn immediately into more than two parties. First of all, because the transaction is supported by the internal processes by both parties, and on the other hand, is because the deal is not concluded anymore by a handshake, but is concluded in different platforms and environments. And that is why I would like to explain you the situation. Currently, we had a McKinsey study in the Western world, and they explained how the bank transfers are performed automatically. In accordance to that study, they were able to decrease the cost of such bank transfer by 80%. That was achieved with the use of technologies for the whole flow of transactions. We can say that this is a very specific area when we speak about banking, and it is not as simple as that, because to identify and investigate the errors in such automatic transfers could be comparable with the benefits which are achieved by the banking organization while using the automated process. Because we need to have a specific person who would be the person to be blamed in case of the wrong decision, or who should be praised in case of the right decision. I was happy to work with the Russian railways, and it is a very prominent feature there. They started digital transformation within the company. They have a lot of different projects, but what is a stopper of that process is that the manager always wants to know who is responsible for a particular decision. It makes sense when we speak about such organizations with such level of risks and danger as railways. What I wanted to say, the dramatic decrease in the transaction cost, which characterized the transfer from non-digital to digital economy, could be achieved only provided that the whole transaction chain can use not the human resources who may make an error and so on, but some automated decision makers. But in this case, we have to trust such automated decision makers on the whole chain. And the previous speakers already mentioned that fact. One more point. When we transferred from non-digital to digital economy, the approach to how economic subjects interact changed, and it changed a lot. If beforehand we were able to say that the economic subject could be opportunistic to some unexpected behavior during the deal conclusion, then now we do not have such an option to be discreet. We have some rules, and the only decision which can be taken by an economic subject is to conclude or not to conclude the deal after all. But actually, even this is not the decision of the player. It's the decision if they agree to play within the necessary set of rules or not to play under that set of rules. And the notion of the new digital trust becomes very important in this case. We need to understand how the digital transformation should work. Here is a very interesting slide with a very interesting picture. It is about growth. You can see the growth trend and also the trend of trust. And also pay your attention to this figure. Those data were published, it was published in 2023, and here in Russia, the number of those people who trust the information in social networks and trade platforms do not exceed 20%. So it fell dramatically when we speak about the trust level. Now we live in a world which changes, which is transactional, but we are moving toward the world where trust to the system into which we live in the current world is very important. I need to refer to my colleague words. He persuaded me with his latest reports that I should not drop the topic, but to elaborate on that, on the contrary. And to continue speaking about the digital trust, I can tell that in this case we need to think about the following factor. We need to think about the economic agents which take the decision instead of the economic subjects. Usually, in this case, we speak about digital agents. That means that the information system is configured according to some particular rules. It uses AI, not necessarily, sometimes it's just a set of rules. In other words, a person just confirms that he continues his work via such a digital agent. Of course, later on, we can have the following steps, such as verification or validation, but from time to time it is labor consuming on the one hand, and also it decreases the point, the benefits from using those digital agents. And this is our future, and this is our near future. Let me skip this slide. We have some notions, some components of the digital trust, and I took that from the Rosen's material. And here is the international paper. This is the results of the study which was conducted by our American colleagues who explored the components of the digital trust. And now I will dive deeper a little bit into the technological part. We analyzed what should be implemented in the digital platforms to ensure that there is a sufficient level of trust to the transaction on that platform. Here is the list. Of course, it's not a comprehensive list. You can add something to that, but those are the key factors of digital trust. I will skip that slide from the Russian railways, and here is the example of the project I wanted to demonstrate just very briefly. This is the predictive analytics process for the fleet in the Russian railways, and the interaction using smart contracts based on that predictive analytics data. That process started in 2021. Naturally, there were difficulties, but this business process can demonstrate how that principle works. We can say that when we speak about the data exchange and the transfer of data between the players in the system, it works better if a human being is not involved. That is just one side of the medal. And the other side of the medal is that if something went wrong, then it's not understandable what went wrong if the human being was not involved. Thank you very much for your speech. Do we have any questions to the speaker? That was a very interesting presentation. Thank you so much. We cannot hear the question because the person doesn't use the mic. Indirectly, yes. But I do not see that we may have some direct impact. Because when we speak about trust, we can see that the person could care about their own role in that process. But the more transactions we have, the higher the level of trust is when we speak about the system. Unfortunately, we cannot hear the question without the mic. And what about the access to different sources which should confirm or vice versa trigger doubts and thus impacts the level of your trust? Does it have any impact? Yes, of course, that factor impacts the level of trust. We have a lot of different studies proving that. And the conditions when the cost of transaction in the economy is lowering down and trying to achieve zero, we need two criteria. We need to have high level of trust and a high level of transparency. Currently, this is something unachievable at the moment, not our reality. I have a very brief question as well. I hope you can hear me. Okay, then the question is as follows. What do you think is the measure for trust? Money, as weird as it can be. And what about social systems? For example, we have the system related to elections. How can we assess the trust of a particular person? Do we use the logarithmic scale for that? Yes, we have two of them, but I think I cannot be able to answer your question within those 2 minutes which are left. And I also have a question. I have a very similar question. When we speak about digital trust to technology, I think that is something which repeats the same idea. So digital trust is a trust within the digital environment which is displayed. Can you provide some formal definition? For example, it's not maybe something binary, to trust or not to trust. For example, I do not know the technology. How can I assess or evaluate somehow if I could trust to such a technology? Let me answer like that. We have some software without any add-ons, for example. And we have a book by Greece about evidence-based programming, where you can have clear understanding what each transaction does, and thus be sure that the system will act as expected. And here we also have a similar situation. We have the technical ability to assess the capability of the system to ensure the trust. And we also have the level of actual trust. And those are two different scales. They are overlapping, and the more zeros are removed from the possibility, the easier it is to reach that so-called technical trust. But on the other hand, if we are continuing to introduce the same ideas to the people's culture, to the culture of acceptance of technologies, the closer we are to the limits of the scale. If it's applicable to the reality, to make sure that we bring everyone into the digital world, it's an open question. It's about ethics.
So we can say that there is a technical trust and a culture to use our software products. They supplement each other or they contradict. They need to be co-used, used jointly. I would like to answer this question. I propose to use a probability. And you said from 0 to 1 that this system, technology, is anyone. And we have a certain level of trust to technologies. It's not always 0.5. And I give like a probability degree to the fact that this technology will meet our expectations. Yeah, so there is a probability that the system operates correctly for its target. Most of the problems are related to the thing that sometimes the systems are not used on the way they're designed to. And when do you plan to start determining the level of trust to the system? I cannot hear because the speakers, they don't use the mic and it's not audible. I apologize. They are talking about not using the mic. So, colleagues, let us proceed. We can stay longer till 2, so all the speakers can have a word. Kirill, please come and take a floor. He is head of Economic Informatics Chair, Moscow State University, PhD in economics, and he prepared his presentation jointly with Oleg Rugachev on the Russian national model on sustainability of enterprises. Shall I have 10 minutes or less then? Like last time, I was given 5 instead of 10. And okay, Yuri announced my presentation topic. Thank you for the opportunity to speak. I want to discuss the sustainability or stability of enterprises. We will be talking about stability at the level of a company, not at the sectoral level, not at the national economy level, but now we don't know what stability at this sector means. Stability of individual companies. Let me describe the conflicts and compromises and how do we consider the digital transformation and how stability depends on the company's goals. This is an intuitive understanding of what stability means. And so the ball will roll down. In the general case, stability, intuitive understanding, this is ability of the system to get back to the initial state under the external impact. Several examples. Another example that I want to show you, and is it stability or not stability? But the brother, the Japanese company, for half a year, back then it was not called a brother. For 50 years, it produced sewing machines. In the 60s, when Japan faced the rapid prosperity period, all the companies, the people, they switched to the ready-made clothes, and it impacted the sewing machine market. In 1971, they produced the first matrix printer. In 1979, they got back to the sewing machines with electronic sewing machine. In the 80s, we all encountered these brother printers, but in the 80s, they started to manufacture RFID marks printer. Is it stability or not stability of individual company? From my perspective, this is a stability. For me, stability is the company's and or systems ability to retain its own basic features while environment is changing. It's not necessarily that the entire initial status is retained. So this is a dynamic stability example. In case of brothers, they retain the property, the management, the key competencies, so ability to make such tricks with switching to the new sectors and acquiring new industrial competencies. But the sector is changing, and competences in the manufacturing area is also changing. Stability factors would we can name as a factor to improve company stability in the modern environment. High share of own capital in passives. My favorite question. Two companies, McDonald's and Microsoft. Which company used venture capital in the early stages? Venture capital. McDonald's. Microsoft was developing with own funds. And stability issue never occurred for Microsoft. And later on, at a later stage, when Microsoft has become a global company, they had their crisis, but it has grown into the gigantic company and still stable and up and running. Different competencies, versatile competencies, or high level of learning ability to learn, and favorable financial options. And I can tell you, if you're interested in and diversification of suppliers and capacity, it can mean that own industrial capacity and capacity that are purchased as a service. So would bring stability down, the high level of borrowed funds, low level of competences, and low learning ability. And the business model is oriented to a combination of economic factors. This is what resulted in the mortgage crisis in 2007-2009, and orientation to a certain optimal supplier, TSMC, for example, where the entire world was relying on. Speaking about management stability, we face this system of coordinates: performance, ability to reach the given goals. For example, ability to reach non-standard goals, like brothers switch to the new sector and still successful performance. Cost efficiency, so benefits, cost and benefits ratio. Both performance and cost and benefits ratio is perceived as efficiency, but as a rule, we sometimes elude the performance. So sometimes we perceive performance as cost efficiency. Stability, we know what it means, and why stability contradicts with the cost and benefits ratio. Borrowed capital under regular conditions is cheaper than owned, so infrastructure and capacity, capabilities that are required to diversify cost money. Diversification prompts you to choose non-optimal suppliers and if the optimum supplier fails, we will have someone to talk to with whom we have contracts, and competences do not emerge. To develop them, it costs time and money. They do not grow by themselves. And stability, one of the areas of stability is growth. Why stability contradicts growth to a certain degree? Because the borrowed funds, they accelerate growth but reduce stability. And if you neglect quality, it can undermine the customer's base. Redundant infrastructure can be postponed under the and also business processes can be changing. So the limitations of growth might increase the stability. An example how to see stability in this case in the balance system of balance scorecard. In finance, the share of own capital in a passive part of balance sheet. In customer segment, diversification of customers, so we don't operate at the narrow market, at the different markets. And from the business process perspective, this is a time to create a new business process, like we need a new task to be tackled. How fast can we create the system that tackles it? And business establishment in new sectors, this is educational development. And also it's important to talk about stability. And this is increased stability. The second line goes towards the right. And these dotted lines, they show the range of a certain indicator. The dollar exchange rate, the interest rate, the price for certain resources. And it's a good example for the oil industry. The cost to extract 1 ton of oil from the well and the range where the company's capital remains to be positive. It is not falling apart. Why I am relating it to the ability, while the capital is positive, it can get back to the initial stage. If capital becomes negative, the company ceases to exist. Digitalization, what it gives to us? Real-time enterprise, of course, modeling of consumers and market behavior. Often, so the stress testers lack of data collection strategy. Yes, we can collect everything and we can make gigantic data sets, but what data sets are needed? What are of the highest priority? What do we process? What we do not process? This is decided by humans. The danger and false correlations, especially while dealing with big data, and do significant impact on the enterprise once we want to manage investments in a real-time mode. But investment management, this is a lengthy process. And how all this situation is related to the targets for the company, to the goals. This is, I paid a lot of attention how to increase the shareholder value. Jensen and Macklin, shareholder value, they say our management is idle. Let us link the management interest to the shareholders' value. Let us reward the managers if they maximize, if they increase shareholders' value. This is a free cash flow. This is economics. Economics contradicts with stability and the limited range of external conditions where the company can function. If we take a look at any investment bank before the crisis situation, before 2007 and 8 crisis, so anything could collapse it. And it happened in this way, but it could have happened in a different way due to a different reason. And so we need to increase the shareholders' value unless the company continues to operate, and so sometimes the state saves the company using taxpayers' money. And the root causes for the problem, yes, I'm wrapping up, yes. The main source of capital, this is a stock market, institutional investors, they optimize their portfolios from the short efficiency perspective to get capital from them. You need to consider their interests. That's why reward for the management in Johnson and Macklin is related to the shareholders' value. We have less role played by the stock market, but at the market, 80% of the investors are not institutional investors, but private investors. And they, so management has a greater freedom. It's like Burley and means capitalism. So the manager becomes an individual entity, but under our current conditions in our economics, as you know, and at least the people sitting here, the steep decline of the planning horizon, and we have an issue with coordination. So conclusions. During the turbulent time, stability becomes increasingly important. Stability most likely contradicts with cost efficiency, but can be a part of performance, not the entire. The root cause, this structure of property and company goals. And in Russia, we have a different property structure, but under current conditions, external coordination is required. The new goal will not emerge by itself. Thank you. Now, we will discuss it on the margin of the meeting. So the floor goes to Marina Anshina. Marina Anshina.
Financial University under the government of the Russian Federation, Associate Professor, Chairman of the Board of the Union of IT Directors, EMBA. Good afternoon to everyone. I'm sorry for such a long name of my presentation. I will try to be brief. Okay, the key architectural trends. Probably you can see them, probably not. From the point of view of development of the digital transformation, that's of course, first of all, the decentralized architecture, because centralized architecture does not comply with the goals of the digital transformation. That first of all goes to IoT and NFT technologies, cloud systems, and sometimes clouds are considered to be new technologies, sometimes they are not considered to be new technologies because they are already widely used. If we speak about the decentralization, in this case we will have some Lego elements. It's just an image when you can construct everything from such small elements. Why? Why we can use anything? Because they are interchangeable, because the parts fit into another part. That is, I think, a good example of how we need to structure our systems, also using the microservice technologies. Now, the point is very important of change management, to make sure that the system is unique, that it does not fall apart. And of course, it's a standard, and then we also need to ensure the quality of the whole system functionality. And if the elements of the system are always changing, then we need to fix something, and we need to fix the connections, because otherwise it's not clear what to fix. That's why I decided to use the Lego image. There is nothing new here. I didn't discover the Americs, and although we do not have a lot of sub-areas in IT area, a lot of was already done. Management of everything, management of transactions, that was already used in the core-based service. Probably you've already heard about that. And that was done to ensure the integration of different elements. And here is the detailed description of the interface. But if Qarba allowed to integrate any applications using any language, using any platforms, then Microsoft allows to do it only for their own platforms, languages, etc., etc. Then I mentioned the keyword interface. Interface is of big relevance at the moment, although it exists already for 30, maybe 40 years. Then we speak about the service-oriented architecture development. It's again about service. Now we have the role model, and then we continue working with the service. Why we speak about the service? Because in this case, it's not only the trust, but also the responsibility of the vendor towards the customer. And I think that most of the students already saw that model. Everything is standardized. We do have language, we do have explanation of interfaces, and we also have the web service definition languages which are used for the connection. I will skip this information because I believe that you are very well aware about it. Then the key features of the service architecture. Actually, when we say service, that will be interesting to dive deeper into that. That is the development of the software on another level. When we speak about service approach, we speak about the possibility to encapsulate the technical implementation, and those services could be implemented in any way, and they can use totally different components. Then flexibility or agility. If we change the element but the service remains the same, we can speak about the stable but flexible system. As for the abilities of decomposition and changes, we have the whole range of such possibilities. And Gartner again returned back the clouds to the technologies, new technologies, and the international standardization starts with the development of reference models. When we implement complicated systems, BPM, ERP, CRM, then vendor would apply the methodology for implementation. And to implement digital technologies, you need to follow the thorough methodology. That's why such methodology is developed by trusted players in the market. Service level agreement. It's not about trust, it's not about probability. SLA is a very specific tool which defines the quality of one element to be provided to another element. It could be some software module, it could be some software system. And I think that most of you understands that term because that was taken from the idea of the agreement. The idea that we used to have some chaos in IT, then we started to use the service model of IT services provision, and then SLA became the foundation. It's not like somebody called us and we fixed the computer, but as soon as the activity of the enterprise depends a lot on the computer networks, on the software, we need to ensure somehow that it will work appropriately. That's why SLA, such as reliability, safety, integrity of transactions, response time to accidents, and so on and so forth, become the components of SLA. And normally SLA is the agreement that goes together with the IT services agreement, which normally provides for some fines or sanctions in case if the executor does not fulfill the necessary requirements. And the whole idea is about SLA. It should be applied to the whole architectural model. Here I have an example where SLA links different architectural layers, but within a layer different components can be also linked. And here we can see the quality of the interaction between the elements, and the system remains stable. I would like to have another remark. For example, the parameters of SLAs of the daughter services can not be worse than the SLA of the parent agreement. And vendors could also be different for each of the layers, but the quality should be ensured. Let's imagine that the software doesn't work and SLA defines the time to resolve the incident. On the structural level, when they will get the information about that on the lower level, then the clearing time would be longer. So the lower the service is, the higher the quality should be. Well, that's actually it. I think I was fast enough. If you have any questions, please ask them. So it's not about trust, but it's actually the same. It's a formalized way. So we promise that this or that element, and they could be very diverse elements, provide the service of this quality level. In this case, we define not only the service, but also the quality of the service. That allows us to build a pretty stable model for nearly any enterprise in any industry. Thank you. And our last speaker, to conclude, we will give the floor to Yuri Lyamin.
Okay. The presentation will be on traditional informational systems. Can you hear me? In this case, I'm speaking as our chair representative from and Vashod University that is developing large-scale state-owned systems. And I would like to dwell on certain aspects that are not directly related to the enterprise, but speaking about the public authorities, what we are talking about enterprises is applicable to the public authorities as well. All our public authorities are at least trying to switch and transform their activities, and they are changing platforms. I will not be talking about the factors that prompted it, and we have certain time limitations, but especially recently we just see emergence of interesting solutions, cloud solutions, architecture-based model, Zachman model, Zachman, it can be interpreted differently, and programming technology, agile principle used in it, and certain moments for the public authorities is related to attempt to build one single cloud platform, GEO, and ideas to develop one single architecture, technology architecture. And here we mean implementation of one single technological architecture in the development of information system that need to operate with the public authorities. And here we see serious changes. But the question is that currently we are facing a situation where our ecosystems are already there. They exist already. And some of the key points related to building the next versions of the big information systems for the public authorities, and step by step abandoning the paper-based documentation and switching to the digital. Yes, without paper we cannot do, but we are quickly switching. And mass use of internet technologies to access digital services. Point 3, establishment of powerful data processing centers that ensure storage and access to the information like GOP system. And last but not the least, developed infrastructure for the high speed data transfer networks. And we cannot live without it. Wireless technology is important. And so we do not dispute that we need to switch the public authorities information system to the new digital platforms. Still, I have several questions where I would like to draw your attention to pros and cons. And active use of Wi-Fi simplifies interaction between the customers and public authorities. This is a pro, this is a benefit. But 100% of mobile devices are manufactured beyond the borders of the Russian Federation, and they use proprietary software. And so how to ensure security, how to control access to the resources? And again, this is about trust to the information that we obtain using these resources. And the projects in our classical systems, instead of use of the obsolete and well-tried, dedicated communication channels, this is expensive, like Gosvibor, the state election system. Now we use advanced systems that are based on the VPN channels formation, dynamic formation of VPN channels. It's great, but if we don't have a permanent mode of operation, then breakthrough capacity of the VPN channel is not stable. And at a certain point of time, especially speaking about the regional systems, you know, in the regions, sometimes internet fails, and it might deteriorate the system reaction time. And certain standardization that was proposed, but implementation of such single technological architecture and the standards, and so our programming committees are dealing with integration in the existing system requires a radical revisiting of this system. If we're talking about one single technological architecture that we try to promote, the elements of standardization are there, we need them, but an attempt to bring all the system and use one single standard approach, this is not the best option, because it's well known. If everything is the same, then the system in one region will work successfully, and in another region it will not work at all. We already checked it while using 112 system, and it was done in Voronezh, and we failed to implement it. And powerful data processing center. Yes, it is reducing the cost to buy infrastructure elements. You don't need to buy your own computers. EASP platforms, you don't need to buy XaaS platforms, whatever you call it. And we have certain benefits associated with it, but a question of trust again. And if we give away our own system to the data processing center, the question comes, do we trust? To what degree we have trust and confidence in the personnel that works? Information leaks, 95%. of the issues on information security is related to people. And cloud services enable to reduce this infrastructure, and you don't need to have your own technical specialist. It seems to be a benefit, but on the other hand, our system specialists that operate their own machines, they don't do just the machines, they know the system itself that is running on this hardware. And that's why. And this is a problem. This is an issue, at least. In most of the cases, imagine a simple situation. We propose the system. One system was developed on Oracle. Another system was developed on Microsoft SQL Server. And is a such a provider, highly qualified provider, who can separate the problems related from the software in these databases from the hardware, from the. Do you have such specialists? Not everywhere. So you need to choose the right provider. Use of flexible technologies is a great thing to have, but and unfortunately, it's not really working. Documentation of each and step, and everything needs to be approved by customer. And someone mentioned stack. Any change needs to undergo the federal service of federal state expertise. This is not the most important thing, and the greatest problem that we're dealing with while we do this modernization. This is an import substitution problem. I will not be talking about it, and so many people, they talk about it, and this problem needs to be tackled. The problem cannot be tackled in the shortest period, no matter how much you want to have to do so. But we have a small benefit, and this problem needs to be tackled throughout the lengthy period of time. And we have a possibility to organize a mass-scale training and retraining of existing faculty on the same IT specialty, so they can consider use of existing and being developed domestic software. Unfortunately, our universities have limited capacity. Ilbrusov, Baikalov, we have special labs in certain universities. They are moving towards it, but this is not a mass-scale movement. But the task, my personal opinion, that the task in terms of its scale is can be compared with the mass training of IT specialists in the biggest universities of Russia, and so where our professors got trained. We had the schools of physics and mathematics, new faculties, new chairs were organized on information technologies, and Kitov, last name, he is a known scientist, Lushkov, Viktor Lushkov, Irshov, Andrew so Irshov, Lebedev also. It's clear that we need to train specialists. And before we take this step into the future, maybe it makes sense to look into the past. Maybe a step to the past. And let me finish with this annotation, and you will find out the offer. You need to understand that under our current conditions and people, it's all important. If we have highly qualified personnel in industry, agriculture, transport, in the army, our country will be inconvincible. And if we don't have high-level specialists, we will be limping. And this was said in 1935. It's still very, very relevant. Thank you. So, colleagues, let us wrap up. We have one more video, but we are so much lagging behind. we need to conclude. I think it was an interesting session. All the presentations were interesting. Of course, 1.5 hours is not enough, even 2 hours not enough. Come again, come again. On engineering of the knowledge management enterprises, and we have several collections issued in this year and 2020. You can take it, you can have a look at the publications. In December, we will have large-scale conference and students' conference. And there we will have discussions, unlimited discussions. We can stay longer by an hour, by 2 hours. The subject of transformation. This is our life. And let's make it happen with our own hands. Thank you.